Pressure, pressure. Hello, Umar.
Hi, good morning. Good morning, everyone.
Yeah, so we shall allow people more 5 minutes before we start the session officially. And I just want to take this opportunity to say thank you for those of us who have already joined the webinar. We should be starting in exactly 5 minutes.
Okay, awesome. Thank you.
Yes. Good morning, everyone. Once again, welcome to this webinar on condition monitoring. I'll start by introducing myself. My name is Eric Oyer. I'm in the marketing department at Amotech Africa. So the main idea about doing this webinar is just to share more knowledge, industry knowledge, and just to make sure that all our clients have the knowledge to use the equipment and how this can actually help in increasing efficiency and improving productivity. So I'll go ahead and introduce Jackson, who is our sales manager. Jackson will go ahead now to introduce the speaker of the day. Jackson.
Hi, everyone. Good morning, and thank you for joining us for this session. My name is Jackson Mwema, as Erica said, and it's a privilege to have you on board for this session. And I hope by the end of it, you'll have learned a thing or two about condition-based monitoring and vibration analysis. We at Amotech, we are a test and measurement solution provider, and we have a number of fields that we engage in, that is project and services. We have a repair and calibration lab that is ISO 17025 accredited by KENAS. And we have a number of services that we provide. Other than that, I won't dive into much of today's speaker in terms of what he's going to share with us. So without further ado, I would like to invite Zulfikar Umar, so that he can take over and guide us through. He's one of our OEMs, and the floor is yours, sir.
Hi, good morning, everyone. And thank you very much, Jackson and Eric, for setting up this time for me to spend with your clients. Just to give you some background, my name is Zulfikar Umar. I'm based in South Africa. I'm the Fluke Reliability Systems sales manager for Africa. I have about 15 to 20 years of experience in condition monitoring and specifically vibration analysis. I'm a level 3 analyst. I have a level 2 in infrared thermography as well. I've been involved in many industries, marine, mining, food and beverage, oil and gas. So I hope to be able to share some of my information today with regards to condition-based monitoring. There's two parts to today's presentation. One is the first part would be on vibration analysis, and then the second part on laser alignment. And I think that before I continue, just to ask Eric, you're able to see my screen?
Yes, we can.
Okay, awesome. Thank you. So I'm going to take the camera off. I think it's easier on everybody if you just focus on the words rather than on the face. What I would ask, though, please, is because we have a varied group of people on the call, if you could perhaps just in the chat, just drop your name and the industry that you're in, so whether it's mining, food and beverage, and then the years of experience you've had in condition monitoring. I will quickly have a look at that as I go through. It will just help me to fine-tune the way in which I deliver the discussion. Please, at any time, if you feel you need to ask a question, it's an open floor. I would say just raise your hand and I'll ask Eric or Jackson if they can just monitor that, because I think once I'm in presentation mode, I won't be able to see all of the hands come up. So thank you. And I'm going to put the camera off now and we can start with the presentation. I believe we have two hours. I don't know if that is still acceptable for everyone. I will work quickly through my presentation and I will stop within sections just to give a few minutes for discussion. And if there's a need, maybe halfway to just stop for a quick refresh break of 2-3 minutes or 5 minutes. I will ask Eric to maybe just manage that from his side. Thank you. Give me a sec whilst I get my screen up to presentation mode. Great. Thank you. Okay, so the first part of the presentation is really just about vibration analysis and condition monitoring. And before we start, it's just a few T's and C's that are applied. The information here is shared willingly, and we ask that you take it in that light, and that there's no recordings made other than the ones that are made by Amotech for them to support. So a little word about Amotech and Fluke reliability. Amotech has been Fluke's partner in the region for some years. They are a well-developed team with good technical expertise, and are able to deliver both product and services and support for the FRS product in the region. Okay. So a little bit about Fluke. Fluke reliability is one of a few Fluke divisions that are all part of a US company called Fortive. Fortive is the holding company, and Fluke Reliability is one of the younger companies within that group. We have more than 800 employees, and we are serving out of 24 different countries around the world. Fluke itself has acquired a number of other companies, one of them being Proof Technique. Proof Technique is well known in the field for condition monitoring and laser alignment equipment, both hardware, online, offline, as well as software. And the other company that is also part of the group is eMaint. eMaint is a CMMS system that was developed in the States many years ago. It's been acquired by Fluke. There has been some integration from the Proof Technique equipment so that the input or the data collected in the field can be pulled into eMaint and helps you to manage your works orders and to facilitate, let's say, a digital progression of your works orders from start to finish. More recently, in last year, Fluke Reliability acquired Azima DLI, yet another American company. Azima DLI has had many years of experience in the naval marine industry. They have their own range of hardware, online and offline. But what they bring to the party, which is very interesting for us, is they have quite an advanced automated diagnostic system. So all of the data that they collect in the field can be, through algorithms, is analyzed, 80 to 90% of which is done automatically. Where there are some issues, then they push that over to live analysts to have a look at. So it just gives you an idea of what we are trying to prepare as we go forward. I mentioned that Fluke has got a number of different entities. So there's Fluke Calibration, Fluke Industrial Group, Fluke Network, Process Instrumentation, Fluke Reliability, which is the one that we are talking about today, and then Fluke Health Solutions. That makes up the full group of Fluke Corporation. We've been involved in all parts of the different industries, from power generation, wind and hydro, oil and gas, chemical, mining, cement and steel. Also in automotive, pulp and paper, food and beverage, and to some extent pharmaceutical as well. So what are we trying to do today? Today we are talking about condition monitoring and how to better the reliability and the availability of equipment in your plants. So we've all seen the PET curve here, the time to failure, or that we have on a lifespan of an equipment. And what we're trying to show here is that we are trying early on in using the technologies that we have available to us to try and detect and prevent most of the failures that would occur in that time. So we're talking about predictive to preventative to reactive. In most cases, reactive maintenance is when you have already figured out that there's a problem It's already far along in progression, and there's a very short period of time to failure. Preventative maintenance is your more standard maintenance practice where you take steps to prepare in advance downtimes and shut times to be able to check that the equipment is still working the way it should be. And that gives you a chance to attend to failures and faults long before they occur, giving you more lead time to the actual failure itself. Predictive maintenance is the one that we would like to be in. That is the space where, using condition monitoring like vibration analysis, you are able to pick up and detect faults early on. It is not the only technology that you can use. You are able to use oil analysis, especially for gearboxes and compressors, ultrasound for your steam traps, and your very high frequency fault detection. And then, of course, vibration and thermography is a little bit closer to the time when you can start physically seeing that issues are happening. So the idea is to install equipment, acquire the data, enrich the system, and that is where we talk about having enough data to be able to start looking at automated diagnosis, and then to have a connected team that is able to view the data easily and then take action as quickly as possible. So before we go into that kind of realm, maybe just some ideas on exactly what we're talking about when we talk about vibration analysis and condition monitoring. Every equipment in your plant vibrates. It is the aspect of this vibration that we want to look at. Sometimes vibration is good. When the changes start to happen and the vibrations start to get more intense, that is when we should be looking out and start having an idea of what it is that we need to do. So the idea with vibration testing is to increase plant reliability and to reduce maintenance costs. Those are the two, let's say, key features of which we would like to pull out from the slide. So we spoke about reliability, and reliability in a nutshell, it's the probability that an asset will perform a required function without failure. And this is what gives us the chance to keep the equipment up and running, to improve our productivity and to reduce our downtime. So there's a typical reliability KPIs or key performance indicators is to try and determine how many failures have we had, what was the total repair cost, how long to failure, and how long does the failure affect our productivity. So these are kind of the KPIs that we would want to manage, and these are the kind of KPIs that you would be able to work with in your CMMS system. So as discussed earlier, and just to go to the basics, the first part of this presentation is really just to solidify in your mind exactly what vibration is and why it's important. So in simple terms, vibration is a response to some form of excitation. Essentially, with a motor, you have a driving force, you have a speed. That speed causes a vibration on the equipment, and the let's say the condition of the equipment can be monitored and explained by the type of vibration that we are seeing. So we measure vibration, or we look at some characteristics of vibration. Is the amplitude, how high are the vibrations that we're seeing, the frequency, how often do we see them, and the phase, how is it in relation to the other vibrations that are coming from the machine. So typically the phase would relate it to the driving force, and in most cases the driving force is the speed of the motor. So those are the three things that we look at on a vibration spectrum. Is the amplitude, how severe, frequency, how often does it occur, and then of course how does it relate to the driving force. So when we measure vibration, we measure vibration in different ways. We have a displacement, which is describes the distance traveled by the mass, or the movement in millimeters or micrometers of the equipment, the velocity, the speed at which this displacement takes place, and then the acceleration is again the rate of change of this velocity. So these are the three ways in which we measure the parameters for vibration, and we'll talk about this a little bit more as we go in. So if we were to look at what we can see or feel or hear whilst we are looking at these vibrations, typically you would see displacement. If you are looking at a machine and you can actually see the movement of the machine, that would be you would be viewing displacement. Velocity is typically what you would feel in the sense of a vibration. You might not necessarily see the equipment moving, but you will feel that the equipment is vibrating. And then if you're looking at acceleration, this is something that you typically would hear. So you might not see it or feel it, but you will hear that there is change. So if you look at that in the frequency range, you can see that the lower frequency range is the movement, the physical movement. The low to mid frequency range is the velocity movement or the feel. And when you start to hear things, you're looking at the high frequency range. And normally when we talk about things like shock pulse, this is a specific kind of, let's say, technology that we use for bearing detection. This is, you will not see it, you will not hear it, you will not feel it, but it is happening at very high frequencies that is out of the range of human condition. Okay. So there's different levels in which we would like to look at the vibration. The overall measurement gives us an indication of what the overall vibration is for that machine. And we would just give it a figure. Let's say, for example, say 10 millimeters per second. And that doesn't tell us anything more than that the machine is vibrating at 10 millimeters per second. If we now compare that against how it was vibrating prior or in previous history, and we see that the 10 millimeters is higher than, say, the 8 that was standard for the last week, then we now know that there is something changing and that the vibrations are now getting to a level where we would need to start being concerned. So the overall measurements usually are trended over time, and that gives us an indication of machine health. So if we look at the trend that we can see on the screen here, you can see that certain alarm levels were set, and then you can see the trend in blue, and these are just trending the overall vibration levels. And what we will see is that with time, the vibration levels start to increase. Once they start to cross the warning or alarm alert levels, that is when we need to start taking some notice. Typically, you would have an equipment that might touch or cross an alarm level and then may settle for some time. So that would be like a first indication that something is happening and that you need to start now maybe keeping a little bit more of an eye on this equipment. And then as that particular problem progresses, you'll see that it will start to cross the alarm levels a lot more. And this is now when you need to start taking some kind of action. If no action is taken, you'll find that it will reach a point where it now has come to very close to failure. You've now crossed the alarm levels, and the trend remains higher than what it was before for a short period of time before it fails. Once it fails, or once you've taken some action, you'll see that the trend will then settle to the levels that it was at previously. So just some idea of how we measure vibration. Vibration is, as a standard, is normally measured as vibration root mean square, or RMS value. In some cases, we will work with peak or peak to peak, or with an average. But across most of the standards that we work with in industry today, velocity is measured in RMS, acceleration in peak or peak to peak, and enveloped acceleration in peak. So if we first looked at the level 1, we're looking at just the overall vibrations. When we start looking at level 2, we want to know something more. So we want to look at spectrums now and start to determine what it is that is causing the fault. So where is the high vibration coming from? So if you look at the equipment that we have at the bottom of the screen there, it's a motor coupled to a pump on the left-hand side. And you can see that they've gone down to show the different components that make up a motor and the different components that make up a pump. So in condition monitoring, your motor pump set would be considered your most or your simplest machine set. And that's purely because you have a shaft on the motor with a rotor and stator. You have 2 bearings, you have a fan, and then you have a coupling. So each of these components would, in essence, at a specific speed, would give off a specific signature or frequency. And these frequencies then would indicate where the fault is coming from. Likewise, on the pump side, you have a shaft with an impeller. The impeller has, say, 6 or 7 blades or 3 blades. The bearings on the shaft would be in 2 places, the drive end and the non-drive end. And all of these would contribute to the vibrations that we're seeing. And then, of course, you have the coupling, which is would be the unit connecting the two. And also you would find that the coupling itself would have a number of bolts, and the number of bolts would also give off a frequency spectrum that would tell you when the coupling has got issue or not. So if we looked at a spectrum that we would pull from the data we've collected, we would call this first one in gray a complex spectrum. And it is made up of all of the vibrations that we are seeing coming from the machine or the equipment over the time frame that we are measuring. But if we were to split this into the different components, you would, for instance, see on the red the running speed of the motor. In the blue, perhaps you would see what would be the fan, the cooling fan at the back of the motor, because it has a number of blades. It would then be multiple of the running speed times the number of blades. And then you would see maybe in the green the frequency that is coming from the bearing that is on that motor. So what we're trying to show here is that the time waveform, which is what you're seeing in the gray, can be through the post-processing through the software, gives us an FFT, which allows us to look at, which is a fast Fourier transform, which allows us to look at specific frequencies with amplitudes, which allows us to and tells us exactly what it is that we're seeing as problems. So this would be the level 2 of the analysis, the level 1 being the overall value, and the level 2 now will be looking at specific frequency sets. And then just digging a little bit deeper and to give you a more lifelike example of that, you would see on the left-hand side here a time waveform, a time signal. And you can see in the signal, the data is quite tense or dense. So there's a lot of information there. Sometimes it is hard to see exactly what is happening. But if you just looked at the repetition that you're seeing of these impacts, you would see that there is something that's happening at a specific frequency. And if we were to look at that frequency on the FFT, you would be able to say that these impacts here relate to this frequency spectrum. Whoops, I've got back again. This frequency spectrum here. And if you're seeing along the side of each of these impacts, you're seeing some side bands that would then show you what you're seeing on either side of the frequency here. So a certified vibration analyst would be able to look at this data, look at the equipment that he is monitoring, and then determine where the fault is coming from. And then this is the last slide I have in this section. And this is just to give you an idea of how the levels of progression on the vibration strategy goes. So the overall values, overall monitoring being level 1, which would be your basic entry-level vibration data collection. And then your level 2 is where you're now starting to interpret the vibration signals and look at the frequencies. And then in the level 3, you start now looking at how are these changing? So what are the trends? How quickly, or what is the speed of progression? How soon do you need to work setting up statistical analysis on this? Do you have similar motors or pumps in the range that you can compare against? That kind of thing is where you start now looking at the analysis forecast. So the levels would be very similar to the, like say, the ISO levels that you would get in the training, and it would then concentrate on the different aspects of what it is that you need to look at. So that is just what vibration analysis is in a nutshell, a very, let's say, high level look at it. I will have a second presentation now, which would be looking at how we collect the data. But I would like to maybe perhaps stop at this point and ask if there's any questions before we carry on.
Great. I think there was a question earlier from Peter Masharia. If you can be able maybe to air out and maybe ask the question. We had seen your hand raised some time back. So please proceed.
So Umar, there was a request you reintroduce yourself.
Sorry, I was on mute now. You asked me to reintroduce myself. Sure. My name is Zulfikar Umar. I'm with Fluke Reliability Systems. I'm the sales manager for Africa, working from South Africa. I've been in the field for more than 20 years, condition monitoring and infrared thermography. I have level 3 vibration analyst certification, as well as level 2 on infrared. And I've been working in a number of different industries: mining, marine, food and beverage, oil and gas, pulp and paper. I hope that helps.
Yeah, thank you.
So there was a question, but I don't see it in the chat. If you'd like to unmute your mic and ask the question, I'm happy to take that now. Okay, maybe not at this point. If there's no questions, then I'm going to just change my slide and go to the next part of the presentation.
Zulfikar, there's a question on the chat.
Just check that out. Give me a sec. Okay, so the question was asked, the Fluke 805 vibration meter, is this a good meter for these applications, or is the 3561 better? Okay, just give me a sec. I have on my presentation something that's not working right. Let's take that off. There we go. Okay, so the 805 vibration meter is what you would call a level 1 unit. It is gives you an overall vibration. It gives you an overall vibration in displacement, in velocity, and acceleration. And it also gives you an indication of what the bearing condition is. So these values are, let's say, spec'd against an ISO standard, which I think is the 10816-2, which is the standard for vibration on land and on stationary equipment. So this is a good place to start. It gives you an overall value. It requires that you do this repetitively so that if you're going to a specific machine, you collect the vibration data. You need to do this at the same measurement point each time under the same conditions. So if the equipment is a compressor, for instance, you need to know that the compressor is offloading at 80% when you take the vibration data. And then when you do that again, the next time you need to know that the compressor is offloading at 80% when you take that reading again. Take the readings as close to the bearing as possible. And also at the same position. It's always a good idea to mark the position on the machine so that even if you're not the one collecting the data, then the next person comes through, they will collect at the same position. That way you are able to measure apples with apples and you have a very good trend of how the equipment is working. So there's two parts to that. Number one is repeatability of the position, which I'm going to cover on the next part of this presentation. And then the second part to that is to make sure that the condition that the machine is operating in is relatively the same. That way you get measurements that you can compare, and that will give you a good indication of how the trend is changing. So you speak about the 3561. Remember, it depends on how progressive your condition monitoring program is and what it is that you're trying to get out of it. So you have the wireless sensors. They are a good fit for some types of equipment. It's usually good when you cannot get to the difficult places. Sometimes at the top of a cooling fan, cooling tower, the fan is sitting there. It's too hard to get to. Then you use the wireless systems to put the sensors in and take the data. What you find though is that these wireless systems don't take data all the time. They have to be preset to take at a specific time, and you have got to be sure that the conditions of the equipment is running at that it's not changing, so that you have that repeatability on that. I hope I've answered that question. Okay, if there's any more, please add it to the chat and I will pick it up as well. Thank you, sir. So I'm sharing the next part of my presentation. I just need to get my speaker notes. There we go. Okay. So when we start talking about severity levels and acceptance testing, so collecting vibration data is a good start, but then you need to compare it to something to give you an idea of whether or not the vibration is acceptable or not. And typically you would find that as the equipment starts up and it has its run-in period, it will be at slightly elevated vibration levels. It will then settle. And an example of this would be, for example, when you re-grease a bearing. At the beginning, when you grease a bearing and you start up the machine, the bearing will be at higher temperatures. And whilst or as the lubricant starts to wear in and becomes less viscous, then the temperatures start to drop. So then you know that the machine has worked its way in and you're now sitting at the, say, the normal operating condition. With time and with wear, your normal operating condition would start to change. You will start to get higher vibrations, and then you'll find that the vibrations are starting to increase. Sometimes it's slow, and at other times, depending on the speed and the application, these could get quite high very quickly. And so that can escalate quite quickly. And this is what this is trying to show you here. You need to know where is the normal operating conditions, and then where is it acceptable levels before you need to start working on preventative maintenance. So the acceptance tests generally standards or measured against standards that have been developed over time. ISO is one of them. Then you have some very specific industry standards like VDI and API. And these might also be based against OEM specification as well. So with the equipment, you will receive some kind of standard, which would be the, let's say, the guideline with which you would decide or determine the condition of the equipment that you have. So defining the acceptance tests according to the machine failure modes. This is something that is done by a standard, for instance, like the ISO 10816-2, or that is the one that is standard for most equipment on land, and that's stationary equipment, meaning not mobile equipment like trucks or that kind of equipment. There's a lot of discussion around the standards. They have been around for a long time, and they are quite well governed by ISO. When you do the Mobius or the ISO or the BIND training, they speak quite a lot about this. A lot of the OEM equipment for condition monitoring equipment set their standards against the ISO standards. But bear in mind that this is also just a let's say a starting point. If you have a lot of history on your equipment, you will find that sometimes equipment like to perform either higher or lower than the ISO standard. That doesn't necessarily mean that it's a bad performer. It just means that in that particular application, in that particular environment, that equipment works ideally at maybe slightly higher or lower. So the ISO standards are usually a good place to start, but you will find with your trending history that you will start to change your acceptance levels for that equipment based on your history rather than on the ISO standard. So if we were to look at a little bit more complex machine, this is now a motor and a gearbox. Then you start to see that the spectrums also start to get a little bit more complex. The more complex a machine, the more components that are there, and the more frequencies you will start to see coming through on the fast Fourier transforms or the FFTs like you see here. So to someone who has had some experience with condition monitoring and vibration analysis, if we look at the FFT on the right-hand side here, you can already start picking up some kind of common faults. You would see, for instance, that there's a 1 times and a 2 times here, which typically points to imbalance and misalignment. You'll also see that there's a multiple harmonics there, which might look like it's showing you some kind of looseness on the equipment, maybe a loose coupling or maybe a loose bolt on the motor foot. And then when you start to look at the higher frequencies, you will start to see that there is rotor bar or stator problems that are happening here. And then on this left-hand side one, you can see where the gear mesh frequencies are and where they start to show up. Okay, so this is just a representation of what we can pick up from the vibration readings that we are taking from the machines. And then once we have these vibrations, we now need to look at the standard and see where does this fit into and how do we use the standards to determine the severity of the problem. So if we are looking at, for instance, the ISO 10816-3 system, it breaks it up into 2 groups of machines, large machines and medium-sized machines. And then depending on how the foundation is, you can see that the vibration levels change. So a newly commissioned machine can work very nicely up to 3.5 millimeters per second RMS. It is still acceptable up to 7.1 millimeters RMS. But once it moves into 7.2 up to 11 millimeters per second, you are now in a restricted or not good for long-term use. And then anything above 11 millimeters per second is considered very high. So you would look at this and say, well, that's for a flexible machine. What does that mean? It depends on how your machine is mounted. Is it mounted very rigidly to the base, or does it have flexible vibration mounting or of vibration pads that allows it to move? So typically on a fan system, you would have a flexible mounting, but on most other equipment, you would have a much more rigid setup. So when the system is rigid, the acceptance level gets a bit tighter, which means that where you would have accepted 11 millimeters per second as the top end of the restricted yellow, for a rigid equipment at 7 millimeters, you would already start having an issue with that. And that's for a large size machine. For a smaller or medium size machine, anything above 4.5 millimeters per second would start giving you some cause for concern. So that's just an indication of how to read the chart and to see where your vibration levels start giving you an idea of the severity of the problem that you have. So you have also the 10816-7, which is normally on rotor dynamic equipment. And you'll see here that, again, the way in which you look at the severity levels is very different. Anything above 6.5 millimeters per second on a smaller unit would be considered a problem. Okay. And then this gives you there's 2 pages of this, which is the different standards that are connected to different types of equipment. So for the test code for airborne sound, you'd be looking at the ISO 8579-1. For gas turbine acceptance testing, you'd be looking at the ISO 2314 from 2009. And then for turbo compressors, you'd be looking at the 5389 from 2005. So ISO has got some really good guidelines for different types of equipment. And if you're not sure and the OEM has not given you some good indications, it's always a good idea to go to the ISO to get a baseline. And then, like I said, from the information that you're getting and the data that you're collecting over time, you can then adjust that to show the levels either higher or lower for your specific equipment. Okay, so this is just another one showing all of the standards for different types of equipment. You've got internal combustion engines. That is your standard 8528-2 from 2005. A lot of these have been updated recently, but these numbers still stand and are quite they're still active in the field as we have it today. Okay. So when we start looking at vibration levels, and we're now spoken about overall levels, we've spoken about the frequency sets that we are starting to see in the spectrum. We've spoken about the severity levels based on ISO standards. And then we now need to start looking at where do we start collecting the vibration data. So the importance of collecting the data at the same position each time is important so that we have comparable data. And then also, why do we look at vibration data in specific directions? So vibration is very focused in direction, and sometimes you will find that the vibrations in the vertical plane, for instance, are not as high as you would see them in the horizontal plane or in the axial plane, and each of these would then start to tell you different things about the faults that you are looking for. So if we were to look at a vertical pump set, and we would look at how we would collect the data, anything in line with the shaft is typically known as your axial plane. and then anything that is 90 degrees to that is known as your radial plane, and your radial plane is then split into vertical and horizontal. Vertical being anything facing to the ground, and horizontal being anything that is 90 degrees to that. So in collecting data on a vertical pump like this, you would really only collect on the axial plane and the radial plane, and then you would call the radial plane either from convention would say, for instance, like the clock, the 3 o'clock position or 6 o'clock position or 12 o'clock position. If you're collecting on a normal bearing housing, then your horizontal plane will be on the left-hand side here. The vertical plane would be from the top, and then the axial plane would be in the plane, in the axis of the shaft. Okay. So we can collect vibration data. We've spoken before in 3 ways. We can measure it as displacement, velocity, or acceleration. And we would use different types of sensors based on what it is that we're trying to gauge. So on white metal bearings or non-roller element bearings, we would typically use a displacement probe because the shaft is really sitting in some kind of fluid, and you don't have rolling elements that would contribute to some of the frequencies you'd like to see in the spectrum. So typically what you would do is you just set up a displacement probe to see what is the movement of the shaft in millimeters or micrometers. And that would then give you an idea of the kind of wear you're getting on that fluid bearing. You can then use either a electrodynamic velocity sensor or a piezoelectric accelerometer. And nowadays, the standard is to use accelerometers for both velocity and acceleration readings. And the software then does the processing to get your accelerometer acceleration reading to velocity. And the reason for this is that you have a much higher frequency range that you can measure through on accelerometers, whereas with velocimeters or velocity sensors, you have a much lower frequency range that you can work with. They're still used in industry, but they have a very specific range of or need, and typically you would only use accelerometers for the rest of plant. So this is another chart just showing you again how the ISO standards are shown. There are a number of different charts like these that you can use. The ISO standard ones are the most commonly used, but you'll find that most OEMs will have some kind of specific chart that would enable you to determine rotational shaft frequencies versus the vibrations that you're picking up, whether it's in displacement or in velocity. So what we saw previously on the ISO standards was in acceleration for velocity RMS, and these are now the standards you would get for using the velocimeters and the displacement probes. So depending on the machine type and criticality, several measurement tasks can be defined. As we've spoken about before, you can look at overall measurements, which is your vibration, your DC gap from displacement. You can also look at the spectral analysis and band values from your frequencies. And then you have some more advanced settings where you start looking at run up and coast down, modal analysis and bump tests, and operational deflection modes or ODS, and then orbits for shafts. And then these are all different parameters that your vibration equipment can start looking at for more advanced analysis and detection. So if we were to just look at one specific type of problem, and I think perhaps before I go further, I'm going to just maybe stop again for a quick question break. if there's any questions at this point before we go into unbalance.
There's a question on the chat, Umar.
I see it now. So the question was, which value we can define normal of the old machine for replacing this machine on the Fluke 805. Okay, so it depends on which parameter you were measuring. If we look at an example of, let's say, a fan. So with a fan, if you're using the 805 and you're collecting vibration data on the bearing housings, the velocity readings, the overall values would give you an indication of mechanical issues. The acceleration readings would give you an indication of your lubrication problems. And then you would use the bearing condition measurement that would give you an indication of how the bearing is failing. So if you're taking the measurement and you're trending for some time, if, for instance, the acceleration is changing from 12 to 15 to 24 Gs, that would give you an indication that there's lubrication breakdown. And once you've changed the lubricant or you've added the lubricant, you'd expect that the acceleration reading would go down back to below 12. Sometimes this does not happen straight away because the lubrication needs to work in. So you might find that the lubrication reading would, after lubrication, would go up to, say, 26, 27. After a couple of hours, it would start to settle and you'd now be sitting at below 6 or 7 or 8. So that kind of gives you an idea. You've got to really see what it is that you're doing and what are the values that you're measuring. Jeffrey, you had your hand up?
No, Umar, no.
Okay. I hope that answers your question, Francois. If not, you can add to the chat. I'm going to continue on the aspect of unbalance. Alan, you have a question, sir. A question from Alan. If you're on mute, you can unmute yourself.
Umar, I think according to the setting of the okay,
Yes.
this someone has to unmute them.
Yes.
Okay.
Yes.
Sorry.
According to the setting, which we can collect data in velocity and acceleration and displacement. To have a accurate data, which what is your advice in acceleration, velocity, or anyone we can in any value we can?
Okay, so the standard is for mechanical issues that you want to look in velocity. And when you're looking for high frequency issues with bearing and lubrication, you want to look in acceleration. So most, excuse me, most devices, you are able to switch between velocity and acceleration, and you can then look at both values. So I would normally record both values if I was collecting the data. That gives me an indication, number one, what's happening mechanically, and then number two, what's happening on the lubrication or the bearing side.
Okay. Thank you.
A displacement for me is not one that I use very often. The only time that I would use displacement is when we're working with high-speed turbines, or where we've got white metal bearings. Typically, their velocity and acceleration does not give you good enough change for you to monitor the equipment properly. Okay. Joseph, I've got a question from you. see if I can unmute you. No, I can't. Jackson or Eric, are you able to unmute Joseph? Excuse me.
Joseph, you can unmute yourself. I've allowed your mic.
Okay, I think I've got another question on how would you get the accurate data assuming that you have aged machines? Are there a defined range? So with machines that are older, they tend to vibrate more. And I think you've got to work really with your history. When you've done your maintenance, you've had a shut, you've had a check to see whether the lubrication is fine or the bearings are seated properly. So long as you are happy that the condition of the equipment is running, it's not a problem if it runs at higher vibrations than a new equipment. Again, you would have to maybe refer back to the OE for where he would see it as a problematic machine. Okay. I'm going to move on to the next part now. If there are any more questions, just add them to the chat, please.
Umar, there's another question in the chat.
Is there a speed range for these sensors to accurately obtain vibration data? Oh, okay. So depending on the type of equipment that you're using, you would have, let's say, good response and poor response based on speed. So when we talk about speed in our region, I would say that typically you would have a motor running at 1480, 1500 RPM. If it's a two-pole motor, it would be going up to 3000 RPM, and that would then determine the speed of the equipment that is connected to it. So that would be in the good range for velocity and acceleration for most accelerometers in the field. When we start looking at slow speed, we're talking about anything less than 150 RPM. Then we need to be a bit more careful as to what kind of sensor we are using, because the sensor would fall off. So it has a operating span, and if it's less than say 150, 120 RPM, which is around about, I think, 2 Hertz, if you're looking at it from the Hertz rather than CPM, then you would find that the sensor is not stable in that range. And so there might be some data that you would miss. When you start looking at slow speed equipment or ultra slow speed equipment, we're looking at something that is running anywhere from 50 RPM down to 0.6 RPM. And for these, you need specialized sensors that would work in that range. And that would not be, for instance, for a unit like the 805. The 805 is for general equipment, anything from your normal 2 to 4 pole motor. It works functionally. The question is, what would you recommend for a 155 RPM hydro turbine? Step up gearbox from 155 to 600. So we've got a change of speed here. The 805 is maybe not the best to work on this. You'd be okay for the high speed side, but you would not be okay for the low speed side. There you would need to look at taking data with a good accelerometer, with a unit like the VibExpert 2 or the VibScanner. So then here now you start looking at how do you set up the database. Remember, with an 805, you don't have a database per se. You are collecting vibration data based on a very specific range of settings that is on that unit. So it's an entry-level unit. When you start looking at compressors and turbines, then you want to look at a VibExpert 2, VibExpert 3, or the VIB scanner. Can the Fluke 810 be helpful? Yes. So the 810 is the next level up. What it is, it allows you to build from a template, a machine set, and then it gives you the ability to collect vibration data based against that template. Again, the 810 would have been an entry-level unit. It's fine for most equipment in the field, but when you start looking at very specific things like hydro turbines and for compressors, you would want to go with the VIB Scanner 2 or the VIB Expert 2. And the reason being is that the software allows you to set up the database specific for those low speeds. And it will allow you to pick up more of the faults that you would want to see rather than working with a template that perhaps wouldn't give you everything that you're looking for. I hope that answers those questions. I still see a hand up, but no question.
Yeah, there was a question from a patient. I don't know whether he's still able to speak. Patient, maybe you can go ahead and ask your question.
Yes, hello, you hear me?
Yes, I can hear you, sir.
Okay, my question is, in example, we are using the table.
Yes.
On the table, on the generator, we have a hydraulic system to put up the shaft.
Right.
Patient, we can't hear
And
you.
what is the unit we can use to take data on the generator? That is a hydraulic system on the bearing place for the generator on the table. We can use accelerometer or velocity.
So on I just want to be sure, on the generator side, is there a rolling element bearing there, or is it a white metal bearing?
Sorry, come again?
Is it a rolling element bearing, a bearing with balls and rolling elements, or is it a bearing with a sleeve bearing or a white metal bearing?
Yeah, it is sleeve bearing, and we use a hydraulic to put up the shaft.
Okay.
There is no bearing. Yeah.
So white metal or sleeve bearings typically means there's no rolling elements, which means the vibrations that you get from there are different. Accelerometers don't necessarily work there. You can get some overall vibration readings, and then you need to monitor the change of that. But the best thing for white metal bearings or for sleeve bearings is for you to use displacement rather than velocity or acceleration. So you would have to put a displacement probe there that would be able to see the change or the displacement of the shaft in two directions.
Okay, thank you.
Okay, thank you. Henry, you have a question, sir.
Thank you, sir. So just on top of what I stated in the chat, for the hydro turbine weight is 155 RPM.
Yes.
We have the general bearings in between there. That is for the turbine guide bearing. And when it comes to the gearbox, we have rolling elements from the low speed to the high speed. They are all rolling elements. So I didn't get it clearly what you stated that is suitable for on the gearbox side, because thereafter on the 600 where there are also general bearings in the generator, I would think I had, like you stated, displacement sensors would be ideal for that one.
Yes,
but now
correct.
For the gearbox itself, I would love to know the actual instrument that we might use there.
Okay, so like you mentioned, for the sleeve bearings or the white metal bearings, the displacement probe is definitely the best idea for detection. On the gearbox where you have rolling element bearings, accelerometers work well. And depending on the speed to which it goes down, and you've mentioned here that I think you're going down from or going up from 155 to 600. So you're already on the, let's say, the step of low speed measurement. And when you're doing this, then the type of accelerometer that you use, it should be a low frequency accelerometer. And you should also look at something where you have some way to manipulate the database. So you need to be able to set your parameters better. I see just below that you said the Fluke 810. I would say maybe not. It would be better for you to have a system where you can set the parameters in the software, which will enable you to get the right output data that you need to monitor. Okay.
When you say low frequency, what is that low frequency? Is it from 0 hertz to 2 kilohertz or something?
So you have typical sensors would be from would have a frequency response from say 10 hertz to 10,000 hertz. That would be your standard accelerometer. What we are looking for is a frequency response from, let's say, 1 hertz or 0.5 hertz to about 5,000 or 7,000 hertz. So there are different sensors in the market that you can specifically pick up that would enable you to have a better frequency response at the lower frequencies.
Thank you so much.
Okay, thank you.
Umar, there was another question from Pradeep. Hand was raised. Maybe you can go ahead and ask his question. Pradeep?
Yes, sure.
Or maybe you can share his question in the chat as you proceed to your next presentation, or you're still moving ahead with this?
I've just got a few more slides on unbalance, and then I'll move on to the alignment after that.
Okay.
Okay, I'll carry on from here then. Okay, so on acceptance vibrations, and just maybe to focus a little bit specifically on unbalance. This is maybe one of the, other than alignment, imbalance is probably one of the most common faults that we find on in condition monitoring. Typically what happens is due to wear, you'll find that the center of the geometric center and the center of gravity change. Excuse me. And this is usually due to buildup or to some kind of wear where there's components that have broken off. Sometimes it's cavities or blowholes, pollution, whatever it is, there's a buildup that changes the center of gravity of the structure. And this causes an imbalance, and then imbalance then is changes the vibration that we are seeing and increases the vibrations to levels that are unacceptable. So this is an example. Yeah, it says the reasons for more than 50% of machine damage is due to imbalance. Typically, it happens on fans and pumps, very differently on fans than on pumps. But on both cases, it is something that is sometimes quite easily fixed, and using the right equipment, it can be done. I have a 3-minute video that shows the procedure of balancing very nicely. After speaking for almost an hour, I think I need to just have a sip of water. If it is okay with the team, I would show the video. Is that okay? Just a quick show of hands, please.
Please proceed, Umar.
Thank you. I'll do that. Give me a sec. I'll just change my screen. I just need to confirm you can hear the sound as well.
No, Umar, we can't hear anything. We just see,
okay.
but we can't hear.
Okay, this won't work then. If I can't show the sound, then Let's see. And now?
Still no sound from.
I think what I would like to try then is just maybe talk you through what you're seeing. I still think that this particular gentleman does a really good job of showing how balancing is done in 2 minutes. So just to work you through, he's looking at the fan. He realizes that there is some kind of higher vibrations. The first thing he wants to do is to take overall vibrations across all of the machine points so that he has a spectrum that will again give him an idea of where the vibrations is coming from. This is important because later on I will explain the difference between imbalance and resonance. So the first thing he wants to do is take vibration readings in all planes on the motor and on the fan. And you can see here that he's taken it in 3 directions. He then looks at the overall values and he decides that, yes, this is higher than the standard that is shown on this ISO 10816. And so he now needs to look at where the problem is emanating from. So he now looks at the spectrum, and the spectrum shows him that he has a very high 1 times, and the 1 times component is the one that's indicating that it's imbalance. There are other components there in that spectrum, but they're small compared, and so he's going to go ahead and do the balancing. So first thing he would want to do is to stop the machine, lock it out. Obviously, from safety perspective, he's now putting his phaser kit on so that he can take the speed of the shaft. He's got his vibration sensors in place, and he's now measuring phase and velocity on both the motor bearings on the left and right. This then gives him an indication of where the fan blade that he must look at, which is now numbered, and he's now put a trial weight and he's now taking his second run. So once he takes his second run and he takes with the trial weight on, the unit will now give him a difference from the original setup to the trial weight setup, and will tell him where the next position should be for the weight, which is then put in and welded. And then he runs the machine and takes his vibration readings again to see what the overall values are looking like. Once he sees that the levels are down to within acceptable limits, then he knows that he's done his balancing job and he's complete. Okay. So that was just to give you a 2-minute, 3-minute video of how the equipment, the VibExpert 2 balancer is used to do the imbalancing of the fan. I think it explains it better than the screenshots that I have here. The only other item I would want to look at is that you have again a standard which would then tell you the tolerances at which you can balance a unit. It's dependent on the type of equipment. The faster the equipment runs, the tighter the tolerance needs to be. So for a fan running at 1480 RPM, you could have a tolerance of, let's say, 5 millimeters per second. But for a unit that is running at 3000 RPM, it would be much lower. And this is due to the fact that the centrifugal force on the imbalance would cause the machine to vibrate even more at the higher speeds. Okay, so this is just giving you an example of the type of class tolerances that you would have and what is acceptable for different types of equipment. So grinding machine, very, very high tolerance of 0.4, whereas if you're looking at just the crank gear on a 4-cylinder diesel, 250 is quite acceptable. So this is just a screenshot of what you would expect to see on the VibExpert 2 balancer, and it shows you the position of the vibration as an angle, excuse me, as an angle, as well as a velocity reading. And then once you have changed the position or you've added the weight, it shows you how it has progressed. The idea being is that you want to get all of these vibration levels as close to the center as possible. Okay. So I mentioned that sometimes we have a setup. I think I've got some feedback from someone. Thank you.
So Omar, somebody was asking if the equipment can be used on wind turbines.
Not balancing of wind turbines, no. Not that I'm aware of. I would expect that that would be a very specific type of equipment. I'm going to make a note of that. In my experience, I'm not sure that it has been done, but if I'm mistaken, I will revert back to the group with the right information. But as far as I'm aware, no. Okay. So I wanted to just maybe spend some time on the difference between imbalance and resonance. Typically, what you would find on equipment is that when there is looseness in the system, and the looseness then is at a frequency that corresponds to the forcing frequency that is dominant on that system, what happens is that you have a process called resonance, where the vibrations escalate or increase phenomenally due to that. And this can sometimes be seen as a 1 times RPM in your spectrum. And a lot of the time people will consider that to be imbalanced and try to balance the unit, not realizing that it's actually a resonance issue rather than a imbalance issue. And so if you consider that you're trying to balance the system and you have a resonance problem instead, no matter how many times you do this, you are not going to get the vibrations to reduce enough. And so there is a way to view this. I'm just trying to find my speaker notes again, sorry. And typically using phase, you can actually see on your coast down or run up that there is a resonance issue, and then you can deal with that separately. So I have some feedback. Is there a question? Thank you. I've just muted. If there is a question, please raise your hand and we'll open up the mic again for you.
Omar, there's a question in the chat.
Let me see that. Give me a sec.
From Joseph.
Okay, so assuming you are to install an online vibration monitoring system on a hydro turbine which has been in service for over 40 years without any monitoring system, other than referring to the standards for vibration criticality limits, what else could be considered for such a task in order to determine the right vibration operating parameters and limits? I will be very honest here. We have some really good members in our team, on our service team, that have got years of experience with hydro turbines. My experience is limited. I would ask that perhaps you drop me a mail and I can get you in touch with the right people, and they will be able to answer your question to your point. As far as I'm aware, with a system, if you have not had one particular condition monitoring system in place, we would have to do some trial and error, add, fit some accelerometers for the gearboxes and the displacement probes for the turbine bearings, and then there would be a need to monitor over some time before we have an idea of exactly where the problems are. But I would really suggest first, drop me a mail or work through your closest AMETEK team member and we can get you in touch with the right people who would give you the right advice on that. Okay, awesome. Let's go back to my slide. I've just got maybe 2 more to go. So with resonance, sometimes all that is required is that the system needs to be stiffened. So if you, for instance, you have resonance on a fan system that has got a loose component, if some rigidness is added to the system, it changes the resonance frequency, and so long as it's running outside of the dominant forcing frequency, which is the speed, then the resonance can remain in the system. That's no problem. So the idea is really about determining where the resonance frequency is and also moving it out of the critical speed space. And usually that is by forming some kind of rigid structure that would change the resonance of the whole system. And I think that that was all that I have on the balancing and resonance. And that kind of brings an end to my condition monitoring speech on vibration analysis. I would like to transfer and change over to alignment, unless, of course, there's more questions now. I will just stop for questions.
Omar, there's one more question from Elaine. Maybe you can tackle it before you proceed to the next presentation.
Sure. In which direction of data collection does the imbalance is detected? Okay, so it depends. And if we're talking about direction of sensor, in most cases, vertical velocity measurements give you the best. And that is purely because it is the holding down bolts of the bearing housings will then make a much more sturdy frame. And so any changes there would be shown up quite easily. But in a lot of cases, you'll find that guys will take vibration data in the horizontal plane because that's where you get the most movement. So depending on how the person who's doing the balancing wants to do it. If you want to see big changes, then you will see it in the horizontal plane rather than the vertical plane. Sometimes by taking vibration readings in the vertical plane, you'll actually determine that it's not imbalance, it's actually loose mounting bolts. So in both directions. And this is why in the video, the guy starts off by taking vibration readings in all 3 directions. And then when he does his balancing, he decided on taking the vibration reading only in the horizontal plane. Okay, I hope that answers that question. I'm just going to change over to the next part of the screen presentation. Excuse me.
Hello.
Hi there. You can go ahead with your question.
Yeah, just a quick one. When it comes to the motor and pumps, at some point you're unable to get the data on the NDE side. Probably the cover for the fan is there and it is not so safe for you to remove it when the equipment is running or something like that, and you don't want to stop that pump only for that. Is it recommended to proceed with only the DE side and also the DE for the pump?
Okay, so depending on the size of the pump, if the position of the drive end and the non-drive end is not that large, taking a vibration data on only one side can sometimes give you the information you need on the non-drive end. It's not always the case. but it can be done. And in cases like this, you've also got to look at what are the ways in which you can circumvent these issues. For instance, you have a casing cover. Are you able to in any way fit a sensor that is permanently there so that you can always collect that data without taking any safety covers off? If that is the case, that would be the recommended action. If in the case where you cannot get to this position and you're struggling, then try and find a position where there is enough material for you to have vibration transfer. So I say this in that, you know, if you're going to put it on the cover, it's a thin material, it will vibrate more than necessary and it will give you poor data. But if you're putting the sensor maybe close to the foot, which is a lot more solid, and the foot might be in the same plane or close to where the bearing position is, you can expect that there will be some kind of bearing a vibration transfer through the foot. And so you can take the vibration data there. It's not ideal, but it will at least give you some indication of what is happening rather than nothing at all. So I would say in that case, you would need to be thinking outside the box a little bit. Understand that the data you're taking might be not as accurate as you'd want it. And then you would have to react to changes in that vibration much faster than you would normally, because now you're not sure of what extra vibrations you are getting in from there. Does that help, sir?
Yeah, it helps. Then also on the other hand, in the event, because there are some motors where they only provided the actual point, and on the side of on the radio point there is nothing. So is it okay to put the sensor at maybe an angle of like, let's say 70 or 45 on the housing where the bearing is mounted?
Okay.
As long as it is a bit solid, it's not loose.
Yes. So again, I think that, like you mentioned, the fact that there is a solid mounting space that will help to transmit the data better. The position in which you put the sensor, whether it is axial or radial, the reason we put it in the radial position is because your bearing loaded zone is in the radial. And typically it's at the bottom at the position, let's say 6 o'clock, underneath in a horizontal position. And that would be where you would get the best signal. But if you can't get that, some signal is better than no signal at all. What that means, though, is that taking the vibration data in the axial plane instead of the radial plane, you need to be sure that any changes that you see on the bearing, let's say defect frequencies, small changes might be significant. Whereas in the radial plane, if it was a small change, you would say to yourself, you know what, this is still fine till the next survey. In the axial plane, it might be that you would have to react faster. Okay.
Thank you, Mal.
Thank you. Just again, from a show, we've been talking now for about an hour and a half. I've got about another 20, 30 minutes before we close up. My idea or my plan was to talk a little bit about laser alignment. I have a fairly intense presentation, but I have a separate one which just covers some of the aspects like the cost implication of alignment. And I think I would rather focus on that one rather than the full-on in-depth alignment discussion. Eric and Jackson, if you're okay with that, I'll go ahead on that one.
Yeah, please proceed, Omar.
Okay, awesome. Thank you. I've got a question from Daniel. Okay, I see your question. It says, could you please organize another session on analysis of vibration data, etc., spectrums, harmonics, sidebands? Yes, of course. This one was I think, just an introduction. I would be more than happy if Amotech would like to set up a second round for something more specific. And even I would suggest if the people on the call would say to me, you know what, let's talk specifically about pumps or fans or compressors or gearboxes, I could then maybe do a presentation specifically on analysis on that. Okay. Jeffrey, any comment from you, sir? No, all good? Okay. The presentation I have here, just
maybe you can showcase the equipments that we have for vibration.
Yes, I can do that. Would you want me to do that now or after I do this 5 minutes on the alignment stuff? Then I can do both together.
We can do it after you're done with your current presentation, please.
Okay, awesome. So when we were doing the vibration analysis portion, I mentioned that there was two major failure modes that affect machine in most cases in the field. The first being imbalance and the second one being misalignment. And if we look at the slide that I'm showing now, it shows that over 50% of machine failures are caused by misalignment. So it might not be that the misalignment inevitably caused the machine to fail, but it was due to misalignment that certain things happened. For instance, seal wear, coupling damage, bearing damage, and high vibrations on machines are all caused by misalignment. I just need to find it. So we can see that all of these, although they might not be high on your visibility list, a leaking seal is a very good indication that your alignment is out. High temperatures on both the bearing drive inside and the pump drive inside also points to misalignment. And something that we don't normally look at, but will also give you an indication of misalignment, is energy consumption. And I think that that's what I wanted to bring home. But before I do that, just to give you an idea of how the type of alignment processes has changed over time. In the past, we would use a straight edge. As a joke, they would call this guy the wizard because he would come out there and put his straight edge, take some time and align the coupling as best he could. With time and with technology changing, the specialist was born and he would use the dial gauges, not the easiest way, most easiest way of doing an alignment. It takes a lot of time, but you'll find that the level to which he's able to align the equipment is now gone by another 1/10. So where you're talking about 1/10 of a millimeter, you're now talking about 1/100th of a millimeter. And now with laser equipment, the technician can come in and do the alignment to 1/1000th of a millimeter. And the idea being here is that it doesn't matter the level of expertise of the technician. The laser alignment equipment itself enables every technician to be as good as the next one. How does this mean to the actual alignment spec? Most of your OEM will show you what the coupling can be aligned to, or the type of misalignment that is acceptable. And depending on the type of coupling that is being used, you can have more or less misalignment. It's also dependent on the speed. The slower the speed, the more misalignment is acceptable. The higher the speed, the more the tolerances need to be tighter. But the one thing I wanted to show was studies have shown that regular alignment checks on your equipment have led to 30% drop in repairs. And this is over the life cycle of the equipment. You know, you can look at the top one. It shows you that over a period of time, you can reduce the number of repairs on your pumps, and you can increase at the same time the life of the bearings on the equipment, and reduce the number of the percentage on the seal repairs required, and the last one being the power consumption. And I think this one for me is quite important. It's something that we don't look at very often. The power consumption of a equipment can be reduced by up to 10% over its lifespan. And there is a calculation that can be done based on the rating of the equipment, the size, the amount of misalignment that you have, the cost of the power that you are using, operating on. This was done for a customer in South Africa in Rand value. And you can see here that from a misaligned unit at 0.75 millimeters misalignment, the cost of electricity for that particular unit over a period of time was 14,786. And once the alignment had been done and to spec, the cost on that same power consumption was 600 Rand. So that is almost a 23.5% higher cost of electricity or power consumption on the unit because of misalignment. So just to cover as a summary of it all, the bearing replacement and the seal replacement, pump repair, excuse me, downtime and maintenance are all reducing, whilst your availability, reliability, operating costs and plant safety are all going up. And essentially that was really all I wanted to show on that. I do have a calculation also on CO2 emissions, if that is one of the KPIs that is also important to you and your business. We can do the calculations to show you the CO2 emissions that you are reduced by every percentage of alignment that you do. So I think it's quite an important aspect in this day and age. Both power and CO2 emissions seem to be the type of KPIs that most organizations are looking at. If you would like to see more of this, I can share with you the calculations for that. Okay. That was all I wanted to show on this presentation. I think we still have a few minutes. I did say I have a very long presentation on alignment, but I think I would rather maybe jump through some of these slides just to give you an indication of what the equipment can do. There's a hand up. See who that is. Okay, I think Daniel, we spoke with you with regards to your question. Let's go to. Okay. So maybe what I'd like to touch on a little bit is the kind of functionality. I need to get rid of that our Rotaline Touch has. That is the Proof Technique equipment, top of the range on alignment. You're able to do a number of different functionality with it. There's a horizontal alignment, soft foot check, vertical alignments. You can do multiple coupling, which means train alignments. That is, for example, where you have a motor to a gearbox and a gearbox to some kind of compressor or other driven equipment. You can do a vibration check. You can do live trend. Live trend is a nice feature. You fit the sensors onto the equipment whilst it's running, and you let the unit take some data. And this allows you to see how the machine is reacting over a period of time and how the shaft centers move. You have RFID capacity. If you've got an RFID tag, the equipment can just be scanned and then it takes you to the same machine where all of its history is saved. Excuse me. And then you also have a camera if you want to take pictures of the equipment before and after the alignment. So these are some of the screens that you would see when you're doing an alignment with the rotor line. First thing to note is that on the sensors, there's a distance marking, which allows you to take the measurements quickly. You have these images. Depending on the type of equipment, you can pull down. It will actually give you a pump or a fan or a gearbox as an image. You can rotate the image so that it doesn't matter on which side of the machine you're standing on. And that just allows you to make it easier for the user to see where he's standing. And you have a different set of, you can set the machine to determine what type of coupling that you have. So as you change the coupling, it will give you the different tolerances that you need. You can also have user-defined tolerances, which means that if you, for instance, know that you have the OE spec for that specific type of coupling or that kind of machine, you can then set the tolerances and save it so that you will always have it for the next time that you do the machine. So there's a number of functionality. We come back to the same screens. I just want to see if I can get to screen. There we go. So now we have a picture of how the sensors are set up. There's also a lot of different settings on the Rotorline Touch, which allows you to do the alignment very quickly. You no longer have to just set your sensors in the 3 o'clock, 9 o'clock, 12 o'clock positions. You can actually now rotate the shaft in any number of degrees, and the system will allow you to pick up your alignment from that. I just want to see if I can get you to show you that. So this gives you an indication. As you rotate your shaft, the sensors are taking multiple readings as they go along. Once the colors have changed from blue to green, it will give you the readings of what you're seeing. It tells you the quality of the measurement that you have taken, how many readings it's taken, and what number of degrees that you've gone through the rotation. And this is called the IntelliSweep function. So you can set it to take readings at your standard 3, 6, and 12, or you can go to IntelliSweep. It takes readings as you rotate it. All along the way, you've got these directions that are coming up to show you what is the next thing that you need to do. So even if you haven't done an alignment before, the unit will walk you through step by step as you need to do it. So you've got either the multi-point, IntelliPass, or IntelliPoint settings that you can work with. And the IntelliSweep also allows you to work out what is the quality of the measurement that you're taking. If you're turning the shaft too roughly, it will tell you stop the measurement because you've got too much vibration. And so it can help you to train your staff in taking the measurements in the correct manner. This is again just showing you all the different measurement types. The most important measurement or parameter that I would like to point out about the Proof Technique range is the fact that you have only one laser and one sensor. Most of the other competitor units in the market have a laser and a sensor, a detector on both sides. And the single laser sensor setup enables you to do the preset and the setup and the alignment much faster. Assume that you have a machine that is very badly misaligned and you have the sensors on both sides. Then you will find it harder to bring those sensors to an agreed point than you would if you were only sending the sensor laser from one side. And I'll try and show that to you in a little while. So this is just some visions or pictures or images of how the IntelliSweep works. I think I'm running out of time a bit, and I don't have time to go through all of this in detail. But what I would suggest is that if you have a specific need to have a discussion or another presentation specifically on the Rotaline Touch, we can do that. I think that the condition monitoring, so the vibration side of this discussion went on further than or longer than we were expecting. But these are some of the parameters that you can get out of the alignment. And when we speak about the IntelliSweep, it gives you a good indication of how the rotation was done, in what direction, the speed of rotation, and all of this gives you feedback as to how to do the alignment better the next time. What's also nice about this is that you can measure your misalignment and then also show it or add your dial gauge readings as well. So it's taking from the older technology and allowing you to present that in your report with the newer technology. And I think that I would want to stop there and maybe perhaps ask if there's any questions at this stage. There was a request to show some of the equipment. I think maybe that's what I'd like to do now. But whilst I'm changing screens, if there's any questions, please free to go ahead. There's no questions so far.
We have a question from patient. You can go ahead and ask your question, please.
Sure.
Patient, are you there?
I have a short comment there from Henry asking, I wish you could touch on thermography. Thermography. So although I have some experience in thermography, it does not fall into the range of Fluke reliability equipment. It does fall into the range of Fluke industrial equipment. I think that maybe we could do a separate session on that, or add that to the next plan. I see patient says he has a microphone problem. If you're welcome to type, sir, whilst we continue, and I'll see if I can answer that in a short while. Just looking at time, we have a few minutes still. I have on my screen now some of the alignment equipment that we have available. The Shaft Align is our entry-level unit. The Optalign being the next level up, with the Rotaline being the flagship with all of the features and the bells and whistles. And then, of course, for the EX version, for the areas where we need it for the ATEX zone certification, we've got the Rotaline Touch EX. Along with that, all of these come with the Alignment Reliability Center software. This is something that I don't see with some of our competitors. When you do an alignment, typically what happens is you have a reason to do the alignment. You go out to the machine, you do the alignment, you print a report, and then you put that in some file somewhere, and it's never seen again unless it's requested for the next alignment. In the proof technique methodology, they have a hierarchy in a software which allows you to go back to the same machines or the same equipment, and you can then store your alignment reports for each time that you do it. This is important in that you have a history that you can refer back to. Sometimes alignment is done on the same machines too many times because there's definitely a problem, but you won't figure that out until you have all of the alignment reports in front of you and you realize that maybe it's not about the alignment, but it's about the structure on which the machines are sitting, and the structure itself is crumbling rather than that the alignment needs to be done each time. So you only start to see these kind of things once you have a history that you can trend, and then you can then change over to the live trend application, and you can see for yourself whether or not it's structural or it's about the alignment. There's a lot of brackets and shims that we have. The brackets allow for very difficult positions, magnetic brackets, brackets for where you cannot churn the shaft, etc. So a lot of this equipment comes with different brackets and then of course the shims. A lot of people don't take much notice of shims when they do alignment. If you're trying to align equipment down to 1,000th of a millimeter and you are using plate metal that is not stainless steel or is not been pre-cut, you are not going to get the alignment results that you want. So they go hand in hand. Although stainless steel shims are quite expensive, they are definitely worth the effort for the time you've put in to make sure that your equipment is aligned properly. That's all that I wanted to say on the alignment equipment, and then I wanted to just very quickly show you some of the vibration equipment that we have. So we spoke about the 805 and the 810. We also have the VibScanner 2, which is a data collector. It's not a analysis module. You have software that you require to set up the route. This is for someone who is just going to be collecting vibration data on a regular basis. You then have the VibExpert 2, where you can do 1 and 2 plane balancing, run up, coast down, all of the other expert modules that you require, ODS, etc., is all on the VibExpert 2 unit. The VibExpert 2 balancer comes with the balancing module already. We have the EX version for the VibScanner 2, and then our newest machine on the market at the moment is the VibExpert 3 balancer. The VibExpert 3 balancer is 6-channel as compared to 2-channel on the VibExpert 2. It allows you to do 4-channel balancing at the same time. You are able to build the route on the device. It does not have software at this point, and they are also adding all of the extra expert modules onto that. So you will soon be able to do ODS and all of the other expert moduling that you want to do that is not available at the moment. But the VibExpert 3 balancer at the moment is available as a balancer only. And software-wise, I think we've spoken about Omnitrend Center. That is the software that we use for the VibExpert 2 and the VibScanner. And then we have a range of sensors required for different applications. So the low frequency sensors, high frequency sensors, and I think that's about all I have to show today. Is there anything that I've missed, Eric, Jeffrey?
Yeah, the 3563.
3563, the wireless sensor?
Yes, yes.
Okay, so we have, let's wear it. At the beginning of my presentation, I mentioned we have a new partner in the business called Azima DLI. The measurement, or the 3563 that Eric is talking about, is one of the products from the Fluke range. I'm going to show you something from the Azima range. Just let me know when you can see my screen. Let's go to...
Yeah, we can see your screen, Umar.
Okay, great. I keep getting this at the bottom, which needs to go. There we go. Cool. So the Azima range of products has a wireless sensor called the Watchman 360. This is what we see here at the bottom of the screen. They also have the online equipment and the handheld equipment as well. But what I want to talk about quickly is about the Watchman 360. The Watchman 360 is an EX rated wireless sensor. It's triaxial. You're fitted one on each bearing position. It then forms a mesh network. It has a gateway. It sends the data through to the cloud via your app. You are able to see or commission the unit. And then the data on the cloud is automatically analyzed. And a report is sent through on the condition of the equipment. And I want to show you. This is an example of a vertical pump where the sensors have been placed. Essentially, you just need one per bearing position. You can have it for a group of machines like this with one gateway. The vibration data then comes through. It's analyzed automatically through the software. And the report is then presented for that equipment. They have over 6,000 rules, 1,200 component faults that they've already set up in the system. And after a few weeks of training, the system works very well with very little input from anyone other than the sensors. So we do have, and I would like, again, maybe just to ask the question, if there's anyone who is interested in the wireless systems. We've got two at the moment, the 3563, which is the Fluke one. And then there's also the Watchman 360, which is the Azima one. And we can work between the two, which one makes the most sense for the situation that you have on site. Okay. And that is 2 minutes to go to the top of the hour. Any last questions, gentlemen?
Umar, there was a question that we missed out on earlier as we started the webinar from Polycarp Nyakundi. I believe he's still with us.
Yes.
So I got this question from the Q&A tab, so I'll just read it out. How can we differentiate between normal vibrations from the normal vibrations, such as earthquake and earth movers?
Oh, okay, that's interesting. So we are talking about condition monitoring vibration basis versus vibrations coming from the ground or from equipment that is running on the side or nearby. They have a very different spectrum. Typically, you would find that we would not look at the overall vibrations, but we would look at the frequencies that we are seeing. A vibration from the earth or from earth moving equipment or from trucks going by typically would not be at the levels we would expect to see for vibrations on a motor or a pump or a fan. So the forcing frequency here would be at a specific frequency. That's the first one. Secondly is that you would see that over a broadband spectrum. So you would see it as noise. It might increase the overall vibration readings that we are seeing, but you would not see it as a fault. You would see it as background noise that you can then take out of the equation through the software. I think maybe that answers the question there.
I believe so, because Polycarp, maybe you can say yes if that answers your question.
And Umar, there's a lot of inquiries about vibration training.
Yes.
Cat 1, 2, and 3. So maybe you can be able to give an answer. So many of them, the participants are asking for this.
Okay, so I think it's very important that training always becomes part of a discussion like this. Proof Technique offers Mobius training levels 1, 2, and 3. They do it in English in Germany. There's also, I believe we can also do it in Turkey. But for the Turkey one, we would need to have a full class for the English version. We are trying to work out to see if we can get a French version done locally in Africa. It is difficult, but I think if we have enough people, we can do that. I don't know if maybe French is probably a good idea for this group. We have also a possibility of running a training in South Africa. If we have enough people on site, we can have a training specific to a customer on site. I think it's up to 6 to 8 people minimum for training. Recently now we ran one training course in Nigeria. So it is possible that we can run a local training at site, but we would need a good amount of people. I don't know if Amotech maybe would be interested in trying to get a number of customers together at one place and then run a training like that there. Mobius is the preferred brand where they do the certification, which is always good. We also do product training. So if you were to purchase, for instance, a unit, either vibration or alignment, we can do a training on site for you to use the equipment. I think it's important that you use the equipment to its best for and to its fullest. If we are not showing you how to use the equipment properly, then you will never get the most out of it. Does that help on the training aspect?
Yes, thank you, Umar.
And then another thing that also comes up with training is also once you have equipment, it's always a good idea to have the calibration done. If your equipment is not calibrated, you cannot then be certain of the information you're getting from it. So if you have old equipment that you have in the field for some years, just check to see what was the last calibration date. And if not, then the best place to start is have your calibration done, have your training done, and then you're good to go with any program that you're running in the field.
Thanks, Umar, for that. And many thanks for such an insightful presentation. I think it's hard to imagine that we've been here for 2 hours. And also many thanks to the audience for setting time out of your busy schedules to come in and listen in. I want to give this opportunity to Jackson to introduce the team from across the region. As you all know, we are not just based in Kenya. We have presence across the region. So Jackson, please take this opportunity to introduce the team so that in case someone has a question from the different countries, because for your information, our audience today is quite diverse. We have people joining in from Tanzania, Democratic Republic of Congo, Uganda, Kenya, of course, Ethiopia. So Jackson, please introduce the team. I have one more announcement to make. I'll make it after Jackson has done the introductions.
All right. Thank you very much. We have a presence in Uganda. We have Ronald with us. Ronald, if you are there, you can just say something.
Yes, am I clear?
Yes, you are.
Thank you, Jackson. Good afternoon. My name is Ronald Arebahona. I see my good participation from my teams in Uganda. And yes, let's continue with this engagement. I'll continue trying my best to bring to you Zulfikar, who is from the OEM, to further clarify some of the issues that you might be having. So yes, thank you very much once again for attending the webinar, and we look forward to more engagements. Thank you, Jackson.
All right, thank you, Ronald. And from DRC, we have two of our key account managers, and we have Nathan. Nathan, you can say something. If Nathan is not,
yes,
okay,
Jackson.
Yes,
thank you, Omar, for the presentation and for the solution that you've explained. And I'm happy to have some of my guests in the DRC. So I've received a lot of message on WhatsApp saying that they need some of those who did not attend the training, the webinar session today said they need a French version of the same training. So I've heard that there's some in the SharePoint. I'll try to find and share with them, or we can also arrange a training in French for for the DRC, both DRC and Congo Brazzaville users of vibration. So that's one thing I want to add. So otherwise, thank you everyone for being there and assisting.
Okay, maybe Moise as well from DRC, you can say something. Moise. As we wait for Moise to come up, I'll ask, we have representative from Tanzania. So we have George, if you can hear me. Okay, I'm told George is already gone to see to handle something in the office. So from that, I'll give it to our Kenya representative, that is Geoffrey, and he can say something.
Good afternoon. Thank you so much for joining this webinar. It has been insightful. I also don't believe it's 2 hours and all the participants can wait for 2 hours. So thank you so much. And with that, I'll allow Eric to announce something in regards to the plans we have for Kenya and for the other countries.
Before I make the announcement, Moise, are you now good to go? Because we couldn't hear you in the last session when you were given the mic. Moise, are you in a position to say something? Moise, are you there? I think maybe he's having issues with his internet. So I'll now go ahead and make the announcement. We shall be having a physical seminar to touch on what has been discussed in this webinar, but now in a detailed way. It will cover both theoretical sessions and practical sessions. The physical seminar shall be held on the 21st of March in Nairobi. So we shall be sending out invitations to the audience in Nairobi. If you joined this webinar, definitely we shall do an invitation to you. To the team in DRC, remember the plan was to have a seminar this month, but due to unavoidable circumstances, we couldn't have it this month, but it's been postponed to April. So also, we shall be sending out invitations to the team in DRC. Same thing, we shall be having a similar workshop in Tanzania. So to the Tanzanian audience, actually, you should be waiting something from us. most people have asked about the presentation. We shall be sharing the presentation immediately after this, just to everyone in case you have anything to maybe get back to what Umar has already covered. We've got you covered as far as that is concerned. To the team, to the Amotech team, I say thank you because I mean, planning for this webinar hasn't been easy because it was on a short notice, and the team from across the region has done a good job in mobilizing, and the attendance has been good. Actually, 70% of those who had registered have actually showed up. So many thanks to the team and to the audience, and of course to the presenter of the day, Umar. Yes.
It's good to point out that we also have these equipments here as demo sessions, demo equipment. So in case you need to see the equipment, we have BIP Expert, we have BIP Scanner, we have the Rotaline Touch. So you can get in touch with any of our key account manager for you to be able to have a live demo session. Thank you.
Yeah, I think now it's a wrap from us, so everyone is free to leave. We shall be sharing the presentation either today or tomorrow.
Thank you, everyone. Goodbye.
Bye.
Thank you, everyone. Goodbye.